All right, one of the things that we previously mentioned when configuring OSPF, and we actually looked at it, was the interface or several interfaces in the F00 or serial that we saw that it was a DR. A DR stands for a designated router, and a BDR stands for a backup designated router. And I stated that that only happens in a multi-access environment. For those of you who are taking certifications especially, this is very, very important because you're going to get a scenario similar to this. Now, what's going to happen here, OSPF is going to run an election. And it's going to decide who is going to be the designated router based on the highest IP address on any physical interface. And what we're going to do, and I'm going to show you now starting from router 1, is we're going to put the IP addresses, but we're going to do it in a certain fashion. I'm going to go from router 1 to router 2 to router 3 and then to router 4. Once I put the IP addresses on there, then we'll go ahead and configure OSPF. And remember what I stated, the highest IP address on any physical interface, that should be the DR. And the BDR, which is the backup, should be the second highest. So let's take a look and see what happens. Let's go into router 1. And it's pretty easy scheme here. We don't have really much to think about. It's the 192.168.1.0 network. So we'll do 1, 2, 3, and 4. Pretty easy. And we will name our routers as we go along so we know exactly where we're at. Host name, R1. We're going to go into the interface, F0/0. IP address, 192.168.1.1, 255.255.255.0. And then we do our no shut and a little shortcut to copy. And we're done with router 1. Let's minimize that. We'll go to router 2, bring up the window so we can see everything that we need to see. Go to this command line interface, hit enter, enable, config T, host name, R2. And we go into the interface, int F00, IP address. So this will be the second IP address. So it's 192.168.1.2, 255.255.255.0. Do a no shut, and then a little shortcut to copy. Very, very easy. All right, at least very easy to configure just to show you this part, but it gets very complex. Enable, config T, host name, R3, interface F0/0, IP address 192.168.1.3, 255.255.255.0, no shut, and then a little shortcut to copy. By the way, you cannot do the do if you are taking your certifications, especially for CCNA. You will have to go back to privilege mode to do that. You have to do a copy run start in privilege mode. Config T, host name, R4, and then interface F0/0, IP address 192.168.1.4, 255.255.255.0, and we do a no shut. All right, so we got, so a shortcut to copy. So we got all the IPs on our interfaces. Now, let's go ahead and configure OSPF in the same order. Router 1, router 2, router 3, and router 4. And let's see who becomes the designated router. So let's go ahead and do that. Now, we really only have one network to advertise. So router, OSPF 1, network, and we'll use net for short, 192.168.1.0, 255, oh, wildcard mask, 0.0.0.255. Area, we'll stick to area 0. Hit enter. Let's do a do WR there. Let's go to the second router. Do the exact same thing. Let me exit once out of interface configuration mode. Do router, OSPF 1. Remember, process ID number. Net 192.168.1.0, 0.0.0.255. Area 0. And our little shortcut to copy. And I'm not waiting for the full loading done. I'm not going to wait for it. We can go ahead and move on to see what we're looking at. And router, OSPF 1, network, 192.168.1.0, 0.0.0.255, area 0, enter, and then do WR, and then the last router, we're ready. We got to exit one time, router, OSPF 1, network. And I typed it out, 192.168.1.0.0.0.255, area 0, do WR. Now, we're going to take a look at our routing table, and it should be funny when you look at it. Okay, I can't spell today. Route, there we go. It's just going to show you the one network that you're connected to, but show IP, OSPF, neighbors. Remember, tab is your friend. Look at all the neighbors we have. And remember when we talked about this key, this two-way, very interesting. Let me put it where you can actually understand what we're looking at. All right, you have a two-way relationship. Look at all our full loading done. It takes a little while for OSPF for everything to come up. But what we're interested in, and let's minimize this, is who's going to be the designated router. It should be router 4, because in this network, which they're all a part of, this has the highest IP address. Well, I'm going to go to router 1, and I'm going to go ahead and type. I'm going to go Control-Z. So let's get rid of all this mess that we see here. I'm going to type show IP OSPF interface F0/0. And we're going to hit enter. And this should look familiar from previous movies. Okay, and then we see here our priority, the type of network we're in, but take a look at our designated router. And it chose correctly 1.4. And our backup designated router, 1.3. So it chose correctly. We want to verify that indeed it does choose the correct DR and BDR based on the IP address, the highest IP address, and in this case, it did. So when we look at the show IP OSPF neighbors command, or neighbor, all right, and again, let me bring this out so you can see it. What is this telling you? That BDRs and DRs create full relationships with the other routers. What this means, and I don't know what engineer came up with this number or this statement, DROTHER, which means designated router other. What that means that the other two routers or the other routers stopped in the relationship process and did not exchange information with each other. So you got routers 4 and 3. Let me minimize this window. So this is your designated router, router 4, and this is your backup. Between these two routers and all the other routers, we have full relationship, but these two routers will not exchange any link state database information. They will send their information to the designated router. They will send their information to the backup designated router, and then it's up to the designated router to send everybody that information. They've created one person in charge of sending information out to everybody else. Because think about this. Imagine if everybody will start updating everybody. If router 2 sends updates to router 4 and router 3 and so forth. So this is the reason that OSPF runs an election on multi-access networks. It could be something like this, or it could be frame relay. Show you just one more thing would be, how can you fix that election, right? You can, and one of the easiest ways of doing it is changing the priority number. Now you saw router 4 and router 3 are your DRs, or your DR and your BDR. Let's go to router 2 over here, and I'm going to change the priority on an interface. By default, all priorities are 1. So I'm going to exit. So I'm going to go inside that interface, F0/0. And I'm going to go IP OSPF priority. And you can see that the priority is from 0 to 255. 255 being the highest, 0 being the lowest, that you will not participate. So I just changed that to 255. I'm going to go ahead and change router 1's priority to 254. IP OSPF priority 254. Enter. Do WR. Now I'm going to do something that you would never, ever, ever, ever do in a real world environment, but just for the sake of explanation, because you need to clear the process for it to happen. I'm going to go to the switch, and I'm going to reload the switch. Don't do this unless you're in a maintenance window in the middle of the night. because everything goes down. You don't want to do that for real. So in this type of environment, lab environment, which I'm sure in all your classes and work environments have a lab environment, you can do that, but not in production equipment. So once this comes back up, because we're waiting for spanning tree to do its thing, what should happen is that now this router should be the DR and this router should be the BDR because we changed the priority. The priority will trump the IP address on any physical interface. We're just waiting here now for spanning tree to do its thing. It takes about 30. Oh, there we go. Well, let's go ahead and go into router 2. And again, it takes a little bit for OSPF to do its process. And full loading done. Remember I said, yeah, that's good stuff. That's what we want to see. Show IP, okay. OSPF neighbors. And let's expand the window. And now what do we see? We see, well, it's still showing that the BDR is still showing as backup designator router. Because sometimes it takes a while for the whole thing to take effect. Let's do the same command again. And boom. Now here we go. Here's your BDR right here, which is router 1, which it should be. And your DR will be the designator router. Okay, so let's go to router 1. Because OSPF takes a while. It's not the quickest protocol of all. So let's Control Z and let's do show IP. Show IP OSPF neighbors. And you can see that the DR is the second router. So you've manipulated the election of OSPF that it runs to see who's going to be the DR and the BDR by putting the priorities. There's a very important concept that I hope you understood. So be very attentive to this particular concept. So I hope it was helpful.